The eval function. This module discusses the eval function involving the user, vulnerabilities and how to deal with them, and where to use it. Let's begin. Eval is a built-in function that passes an expression and runs it as we execute the program. You can say that it evaluates it. This is the syntax it takes. It takes three arguments, an expression, and globals and locals. Expression is the string we wanted to pass and evaluate. This is not optional. Globals is a dictionary holding the available global methods and variables. This is optional. And so is locals. This is a mapping object holding the available local methods and variables. This is a dictionary. The globals and locals parameters aren't necessary, but if skipped, they take up the value none. Globals returns a dictionary of the module namespace, and locals returns that of the current namespace. Let's take an example. None is 7. If we multiply this by 3 and pass this string to eval, we get 343 because 7 to the power 3 is 343. Sending in a nested list to eval gives us 3. Eval only ever evaluates, it does not compile. An if statement in eval raises a syntax error. Sometimes, based on certain conditions, we want the user to provide what to evaluate. We can also have the user provide the value to evaluate using. The input function takes in an expression in terms of x, and we call it expr. This is the expression. To solve this, we ask the user for a value of x. This is 7. Now, when we evaluate it, putting 7 in this expression, 3x to the power 4 plus 4x squared plus 2x plus 6, we get 7419. This way, you can get all the input from the user and simply have your code evaluated. But eval does introduce some vulnerabilities in your code. If it can help you, it can hurt you. Eval is convenient and will evaluate whatever you feed it, but this can be used against you. Using eval, a user can make a call to a dangerous function, one that causes irreversible actions, access hidden and confidential data like passwords, read, write, and delete files on your system. This can be done using the OS module's system function. Not convinced yet? Let's try exploiting eval. Say your code uses a function to return confidential data like a password. expr is the input expression in terms of x. The user inputs a call to the enter function here. Now when we evaluate this, we have the password. It's that easy. So what can we do about it? We can restrict what goes into eval. It won't be able to access anything else. Again, this is the expression in terms of x. We take x from the user. This is 7. Now we create a dictionary safe-ticked. For the key x, we store the value of x and its value. This is the key here. Pay attention. To the call to eval, we pass the expression and this dictionary safe-ticked. This evaluates to give us 7419. What if things weren't this way? The expression is a call to enter. Now since the call to eval has the expression and the safe-ticked as arguments, it does not evaluate the enter function. Rather, raises a name error stating the name enter is not defined. And where do we use this? Although we often refrain from using this unless we really need it, it finds use in the following ways. To allow users to create their own scriptlets, this lets the user customize system behavior and helps provide better user experience. Eval also lets us evaluate mathematical expressions and applications. This evades the need for writing an expression parser. Let's take one more example. We have two functions, double and triple, that double and triple numbers respectively. The choice takes in what to do. The user says they want a triple. We ask the user for the number to triple. This is the number 8. Choice is a string. To this, we now add parentheses and the number 8. Finally, we evaluate it. This is something like eval. The answer is 24. 8 multiplied by 3 is 24. This was all about the eval function, but it only lets us evaluate stuff. So next we'll study the exec function.